Hello students, this is exercises week 3 in course Emerging Trends in Software Engineering. Okay, in this week we will continue with the analysis using the same data as last week, and we will start out by plotting word clouds. Now what are word clouds? They are basically plots on screen so that the size of the word determines its importance. And in a typical case, this importance is the number of occurrences this word has in a particular text or in a set of documents. It can also sometimes be that we expect a certain word distribution and we want to compare another set of documents to this baseline word distribution. And we would use this difference against the expected word distribution and the existing word distribution to determine the size. But this is a sort of a special case. Okay, now we are here again in RStudio. And clean that up. We will start by loading the necessary libraries. So I'm in a file, wordcloud.r, and I have already run the initialization script. Now I just load in the libraries. And everything seems to be working correctly. I set up my file. And I load the file to memory. So now I have my articles, which contains 3,591 papers. Okay, so now we have loaded the file. This prints out information on what is this file doing. Here I paste together the titles and the abstract, as I want to do the word clouds on both. This is by no means necessary, but might be a good idea. And now I convert everything to lowercase. And I definitely, for word clouds, since word clouds in this case are about the number of word occurrences, so I definitely want to remove stop words, which I do in these two lines in 27 and 30. And now I have arrived in line 32, and if everything is well, this should now plot word cloud to my screen. Yes, so it does. Okay, so I'm operating on the data file from Transactions on Software Engineering. And as you can see in the screen, let me just about that. As you can see from the screen, the most frequent word is software, then is system, systems, paper, and so on. So I definitely want to add these to my list of stop words. Okay, and now I have edited the list of stop words. So now I have software, system, systems, can, and paper in a list of stop words. And I would not expect to see them in the word cloud figure. Let's see if this works out. Now we plot. Yes. It appears there is some plotting. Okay. Okay, welcome back. Now I have resolved this problem that you just saw. Maybe it's good that it happened to me, so you can also see the solution. So I have added a scale variable where you can control the size of the largest word and the smallest word. If I set this largest word size 8, which means that the scale would be from 8 to 0.2, we can see that this happens. Now if I set it to 3, see that as the biggest word is only allowed to have a size 3, this looks much better, but still it is a bit too much. It might be even a bit smaller. Let's try, because 2 was too small, so I will try. Happens. Okay. Now this looks good. And why this happened actually when we did the stop word thing is that there were many words that were so considered to be very near the top. But we had a lot of words that were quite large. And in the default scale, it worked all right, or without the stop words. But once we removed the stop words, those most frequent words, then the scaling no longer works. So we had to manually adjust it. Okay, so we continue the analysis with comparison cloud. This is like word cloud, but it highlights if a particular word is more frequent in one group than the others. And from the documentation of wordcloud.r, we can actually find more detailed information saying that the size of each word is mapped to its maximum deviation. So this means that the word size is based on the difference on how frequent it is in a particular set of documents in comparison to the other set of documents. And this is absolute scale, so this is not relative scale. So what this means that this would still prefer very frequent words. Okay, back to our studio. And I'm in the file comparisonscloud.r. And as before, start out by setting out stop words and loading my my data file. Although I already have it, I simply do it from the start. 17 simply prints a message, what is going on. Now here, as we want to split the articles to two groups based on the date, we want to compare the old and the new. We need to remove articles that do not have any dates. There are some such articles and they will cause errors. So we do it in line 20. Now we got rid of those. And now we split in the middle in line 24 and 25. So we take the median of my article.date, and from the screen you can see that it's the 1st of January in 1993 in my data set. And now we split so that we have new titles and old titles as separate variables. We paste them together still for the purposes of plotting. There is some removal of special characters. And now we go to plotting and we hope that this works. Yes, this works. But there is some size issue again. Let me see if I can resolve this. Okay, now I managed to successfully solve this. Again, the scaling variable was missing. Still a bit too small. Try 2.8. Yeah, that's still bearable. And we can see that papers published after or during 1993 have most frequent words of software, test and code, whereas papers that were published prior to that talk about distributed system, databases and programming. And this is that they speak proportionally more about that. I mean, there would be papers about programming after 93, but it is simply that they were more common prior to 1993. Okay, and lower in this file we do a four-way split based on the citations that these articles have been getting. So previously we did split based on the date, but now we do split based on the citation. So we want to see which are the most cited articles. And we try to execute all this at once. These the not so interesting parts. I might just want to explain you that in here the splitting happens. So we give probabilistics of 2.5, 2.5, 0.5 and 0.57. So we get four 4 different groups, 4 different quantiles. So I use this quantile to have the top, for example. And I get roughly 50 papers. Okay, and now we have arrived to the bottom, and now I simply plot. And I can see, scale a bit so I can see a bit better. So I can see that the least cited articles are introductions to editorials or special issue editorials. So they talk about things like, in this issue we have papers about this and that. So they are not scientific articles themselves, but they are about, what's happening in here. And what we can see is that the most cited articles are about software. Okay, so we might want to consider removing this software, so as it a stop word, but they are about testing, empirical methods, and requirements. Okay, so this was it about word clouds and word comparison clouds. So you should do this analysis for all data sources, for Scopus, Twitter, and Stack Overflow. As there are no citations in Stack Overflow, they have been replaced with number of upvotes. And for Twitter, we have number of retweets to represent citations. And so, word clouds and comparison clouds can give you visually appealing results that are actually based on some real data behind that visual appearance. I hope you find this a helpful technique in your report.